Okay, let's have a look at this first one. Looks like a rates question. Got our formula here. Find K, given that the weight is 10. Okay, so we'll start being nice and neat. We write our formula. Okay, find K when the weight is 10 after 50 hours and is T is in hours here, so that's okay. So we're just going to substitute that in. That becomes 10 equals 20 e to the minus k times 50, so 50k. We want to get to k here. We're going to have to get rid of the e by lning eventually, but we must get rid of this times 20 first. So 10 divided by 20, we're left with a half equals e to the minus 50 over k. We now can ln both sides, so I get ln of a half. That cancels out. I'm left with minus 50k. Now I can just get rid of that times minus 50 by dividing. I'm just going to tidy this up a little bit here. So remember, we've got our rule. I'm just going to replace that with 2 to the minus 1. We all agree that that is a half, I hope. And the reason that I'm doing that is because I'm going to use this little rule that ln a to the n equals n ln a. So this now becomes minus ln 2 equals minus 50 times k, and therefore the negatives will cancel out. Get rid of the times 50, we divide by 50, and so that's why we end up with ln 2 over 50, or as you check the answers, they will have 1/50th times ln 2. Now, they're the same. I'd probably leave it like this. I wouldn't rewrite my answer or change it. Okay. Find the weight of radioactive substance at T hours. So we now have that our formula is weight is 20 e to the 1/50th ln t. So when t equals 0, so for part 1, when t equals 0, we end up with the weight, I left the 2 out there, ln 2. So 0 times anything is 0, so we end up with e to the 0, which is 1. 1 times 20, we get 20, what do we got, grams happening there. For 2, that should actually be a minus there. Okay, now when t equals 24, we'll do the same thing. So w equals 20 times e to the minus 1/50th ln 2 times 24. And on our calculator, 14.34. And for number 3, you just have to make sure they've set it as 1 week. So how many hours in 1 week? And then substitute that in. So for C, how long will it take for the weight to reach 1 gram? So 1 equals, I've just gone back to using K because I didn't want to write that whole thing again. So similar to what we did in A, we're going to get rid of the times 20 by dividing. E to the minus kt, we will now ln 1 over 20. Now I can write that as 20 to the minus 1, which means minus ln of 20. You could have just left it as ln of 1 on 20. I'm just tired of writing fractions, bit over it. Minus kt, so therefore t will be equal to, negatives will cancel, ln 20 divided by k, and we've got k down here is 1/50th, 1/50th ln 2. So we pop that into the calculator now and we get 216 0.1, and that is in hours, and if you wanted to you can convert that to days by dividing by 24. Your call. Bit worried that we haven't differentiated anything yet, but hello, here it comes. As soon as we see rate, that means we want to differentiate. Right, time to, as we said, differentiate. So we will write that as dw by dt. We're differentiating. I've gone back again to the k, and I know k is this value up here, which I can substitute in when I get to that point, but just for working out, I'm going to leave it as k. So we differentiate, and remember the rule is we write the function down, so 20e to the minus kt, and then we're going to multiply by the derivative of what's up here. Now remember, k is a constant, so the derivative of that will just be minus k, because if you had like minus 2t, you know the derivative will just be minus 2, so minus kt, derivative will just be minus k. Find the rate at 100 hours. So now when t equals 100, we will go back, we'll replace k with this up here, replace the t with 100, and you can do that. The reason that I've probably called this question up was because I wanted to show you E. Some of you panic when you see proportional to is proportional. Now, if we had, I don't know, let's say, what letter haven't we used? A is proportional to B. To get rid of the proportion sign, we just times something by a constant. So if we can prove that A equals KB, where K is a constant, that means that A is proportional to B. So if we look at our derivative, we've got dw by dt equals 20e to the minus kt times negative k, but this bit here, that's actually w, isn't it? If you look up here, w, so this is minus k times w, and so we are in fact timesing the weight by a constant, and therefore we can say that dw by dt is proportional to w. Okay, so nothing huge there, pretty straightforward.